All right. Well, then I will go ahead and start. And yeah, sorry about the jumpy start here. Again, we are learning a new system. Thank you guys very much for registering and going through this new system in order to join today's webinar. My name is Laurel Glenn, and I'm the program manager for SAFE-D. We appreciate you joining the webinar on the evaluation of advanced driver assistance systems in police vehicles. So as you've noted, you've all come in muted. You can use the chat box to send a chat message to the host or panelists, which is Sue, myself, and Maryam, the presenter today. If you have any questions during the webinar, you can also use that chat box. We can also push it out to everyone so everyone can see it. And we can also hold on to it for the question and answer session, which will be at the end.
And you may, if your chat is disabled, which I think it is for some people, you could use the Q&A box.
There you go. Thank you very much. Again, a little bit of a junky start here, but we're going to get it. And so you do have the ability to communicate with us. The captions should be turned on for your convenience, and your videos are turned off. So at this time, I'd like to introduce our presenter today. Maryam Zahabi is an assistant professor in the William Michael Barnes 64 Department of Industrial and Systems Engineering at Texas A&M University. Her research focuses on human performance modeling with applications in assistive technologies and surface transportation. She received her PhD in Industrial and Systems Engineering from North Carolina State University in 2017. Her research has received support from agencies including the NSF, DARPA, and USDOT. She's also the recipient of the 2021 NSF Career Award and has published 40 journal articles in the human systems engineering area and serves as an associate editor for the IEEE Transactions on Human Machine Systems Journal. So I would like to go ahead and turn it over to her so we can all learn a little about this research project. Thank you very much.
Thank you so much, Laura, for the introduction. Hello, everyone. Today, I'm going to talk about our safety project, which was focused on analysis of advanced driver assistance systems in police vehicle. A little bit background about this topic. Motor vehicle crashes are one of the leading causes of line of duty death for law enforcement officers. And among all public safety workers, police officers are involved in significantly higher number of fatal crashes compared to firefighters and emergency medical services. And when we look at the causes of these crashes, mainly they're due to high-speed driving, pursuit situations, and use of in-vehicle technologies. For example, the computer that police officers use in their vehicle, which is called mobile computer terminal. Also radio, for example. And the other reason is fatigue as well for these crashes. My research mainly has been focused on use of in-vehicle technology and effect of that on police officers' driving distraction and safety. And today I'm going to talk about the effect of ADAS. A little bit about what ADAS systems are. So ADAS are vehicle control systems that improve driving comfort and traffic safety by using sensors and help the driver identify and react to hazardous traffic situations. We are all familiar with ADAS types. Some examples are forward collision warning, blind spot monitoring. And prior studies have reviewed ADAS use by civilian drivers in non-emergency vehicles. However, there are several differences in driver and vehicle state between the police and civilian drivers. For example, police officers drive under high workload mainly. They're using in-vehicle technologies while driving, and the amount of training that police officers undergo usually are different from civilian drivers. So the benefits that ADAS provide for civilian vehicles may not always be as effective for police officers. Therefore, in this research study, we wanted to determine the existing ADAS features in police vehicles. So that was our first objective. We wanted to identify the potential ADAS features that can be implemented in police office vehicles to improve their safety. We wanted to understand officers' opinion and perception on these ADAS features. And our last objective was to investigate the effect of ADAS on officers' workload, performance, and trust. We conducted this study in 2 phases. The first 3 objectives were addressed in phase 1, and then the 4th objective were addressed in phase 2, which I'm going to talk about. So in phase one of this research, we conducted a systematic review of literature first. We looked at some general databases, for example, Google Scholar, Compendex, Web of Science. We also looked at some transportation-related databases like Transport Research International Documentation, TRID, and also we looked at Google Patents because we wanted to identify those ADAS features that might not currently be available in police vehicles, but they have the potential to improve officer safety. The keywords that we used were a combination of assistant features, for example, automation, advanced driver assistance systems. We combined it with group 2, which focused on the users, police officers, and also combined it with the group 3 keywords, which were related to the car, vehicle, and driving. We also looked at the top 3 car models, mainly Ford, Chevy, Tahoe, and also Dodge, as these are the main manufacturers of police vehicles in the US. The inclusion criteria was that we focused on the studies that looked at the effect of ADAS on driver safety and performance. We looked at the active and application granted patents as well. The gray literature were also included. We looked at government reports, newsletters, websites of these manufacturers, fact sheets, and thesis and dissertation. In this figure, you see the Prisma methodology that we followed for finalizing our number of articles that were relevant to this topic. And we found at the end, based on the review of the title, abstract, and the full version of these papers, we found 33 relevant articles and 7 patents that were included in the final review. Beyond the literature review, we conducted an online survey with 19 questions. Participants of these surveys were 73 police officers, 68 males and 5 females. The police officers were mainly from Texas, but we had a few from other states as well. The questions were focused on concepts like the perceived usefulness of these ADAS technology in police vehicles, perceived ease of use of the technology, trust, training, and behavioral intention of officers in using these technologies, because we wanted to conduct the technology acceptance models, which I'm going to show in the next slides. The examples of survey questions are here. The survey included 19 questions. Here I'm showing a sample of these questions here for just examples. The technology acceptance models shows the interrelationship between different constructs. For example, whether trust has an effect on behavioral intention, whether the perceived usefulness of the technology might have an effect of behavioral intention. Other factors include ease of use, training, and demographic information, including age of the officers and experience in using these technology. We had a list of hypotheses. These hypotheses are from the technology acceptance model. For example, the first hypothesis says that when trust in ADAS positively affects officer behavior to use these technologies, or the perceived usefulness of this technology has a positive effect on their behavior intention. So with this analysis, we analyze the data to see whether these hypotheses are supported or not in case of the ADAS in police vehicles. In phase 2 of the study, we recruited 18 additional male officers, mean age of 37 years of old. And then we conducted a driving simulation studies in our high fidelity driving simulator that you can see on the right image. We also asked the participants to use mobile computer terminal, which is the main technology for the officers to use while driving. The independent variables in this study included hazard type. For example, sometimes there was only a lead vehicle that brakes in front of the officer. Sometimes there was a vehicle in the blind spot of the officer, and sometimes there was a combination of these hazards. The other independent variable was the ADAS technology status, whether it was on or off. For example, we had forward collision warning icon. When it was on, it shows on the dashboard, and when it was off, for example, it didn't show anything. We also had a blind spot monitoring signal. And the driving condition, it was 2 conditions, normal versus pursuit, and we also had a non-driving related task, which was this mobile computer terminal. It could be on or off. The driving scenarios included 2 situations. In normal driving, police officers were asked to drive in urban environment, follow all the traffic signs, and the speed limit was 40 miles per hour. In the pursuit situation, there was a lead vehicle that we asked the officers to follow, and the officer could drive up to 60 miles per hour. And there were some occasions in the driving that they had to use this mobile computer terminal to do this secondary task, which in this case was a plate number check task. And the sample of that is shown on the right image, which is an example we got from a local police department. And the dependent variables includes the driving performance, workload, and trust. Workload and trust were measured subjectively using a driver activity load index and also a trust questionnaire. The driving performance was measured objectively. And we had 3 hypotheses for this study. For example, the first hypothesis was that using ADAS would improve driving performance. The second one was that officers would report a lower level of workload when driving with ADAS as compared to manual driving. And the third hypothesis was that ADAS would increase officers' trust in the vehicle, especially in safety critical situations. So with that, I'm going to jump into the data analysis approach that we used. For phase 1, we wanted to see the relationships between responses. Therefore, we use a correlation analysis. We also wanted to study the complex interrelationships among different constructs, and therefore, we use the partial least square structural equation modeling. And in phase 2, we wanted to test the effect of those independent variables on the dependent variables in a driving simulation study, and therefore we use analysis of variance. So the summary of phase 1 results, which was a literature review, showed us that there are ADAS features, of course, in police vehicles, and many of these ADAS features are common with civilian vehicles. However, police vehicles are generally equipped with some temporarily disabled switches so the officers can deactivate some of the features. For example, the emergency brake, in situations such as pursuit driving, where ADAS would be more of a hindrance than an aid. And this is a list of ADAS features currently available in police vehicles. This is a list that we could find from different vehicles. Some vehicles have some of the features, some others may have others, and there is also an overlap between different features. This includes some general features like blind spot monitoring, rear view camera, pre-collision assist, and some more specific features such as safety alert seat, for example, and night vision, and so on. We also wanted to recommend some additional ADAS features that might be able to improve police officers' safety. And we found this list in this table based on our review of literature. So for example, some features like front vehicle detection system, intersection collision avoidance, evasive steering system, left turn assist, traffic sign detection system, traffic jam assist, 2-lane detection, and also autonomous highway driving and wrong way alert. We listed this, but we wanted to find a way to classify these and rank them. Therefore, we use an impact-oriented approach using the author's knowledge and literature. In this approach, the ADAS criteria that I just listed is rated based on 3 criteria. The first criteria is how ADAS features could help with the avoidance of inappropriate speed. And the second criteria was how these ADAS features could help with keeping appropriate longitudinal and lateral distance. And the third one was that how much these ADAS features could help support driver awareness. So we gave a rating of high or low for each feature and then counted the number of high and lows and then ranked based on that. So in this table, you can see these features that we have here and then the total number of high and lows that we counted from the previous approach and then ranking. For example, the front vehicle detection system, we gave high ranking to all of the 3 criteria and then the ranking of these features was 1. And then the last one was autonomous highway driving. The reason why we ranked this autonomous highway driving the last, although it had 2 high values based on the criteria, was that there was concerns with police officers regarding the privacy, regarding the legal issues and cybersecurity in police vehicles, that they did not believe that autonomous highway driving might be a good feature for the police officers. So we combined our rating with police officers' rating as well. So in the online survey, we gave them each of these ADAS features. We provided explanation to each of them, and we asked them to rank it. And from their ranking, we found that, for example, the intersection collision avoidance was the rank number 1, and the last one, as we expected, was the autonomous highway driving. So our ranking was mainly similar, with a maximum of 2 rank difference with police officers' ranking, except for the wrong way alert, which was a large difference. And we believe that the officers' ranking should be prioritized here because they have experience in police operations, which shows that the wrong way alert system might be useful for them. So the lesson learned from our literature review was that no studies was on the impact of ADAS features on police officers' safety, and that actually motivated us to conduct the second phase of this study. And we found that there are some ADAS features that have a potential to improve officer safety, which we included the list here. For example, front vehicle detection system, which can help in pursuit situations. Intersection collision avoidance can be useful when the visibility is obstructed. Police vehicles, they have a lot of technology that can reduce the visibility of officers in the vehicle, and therefore these ADAS features can be helpful when using these secondary tasks and also when their visibility is obstructed. From our survey result, we also asked the participants about the frequency of ADAS features in police vehicles, in their police vehicles. So the list that I showed previously, which shows the available ADAS features, they are based on the available features from manufacturers' websites, for example. However, when we surveyed the police officers themselves, most of them said that the most ADAS features available to them, there are Bluetooth communication systems. It is a rear view camera, and then the ones that are not very often existing in the police vehicles are reverse brake assist and front split view camera. And some of the features that were in the police vehicle websites, a lot of the police officers said that our department do not have budget to buy all of these, for example, ADAS features. So the lack of budget was the main issue that officers mentioned. We also looked at the correlations between responses to specific questions. I want to highlight some of the correlations that we found to be interesting. For example, question 11 says, do you think ADAS features can be useful in pursuit situations? And question 16 says that, to what extent do you think ADAS features would reduce your workload? And these were correlated to each other. So ADAS have the potential to reduce officers' workload in pursuit situations. For example, question 12 and 14 and 18 were correlated. So in question 12, we asked, how often do you rely on ADAS feature while you're performing a secondary task? In question 14, we asked, how much do you trust ADAS features to improve your driving safety? And in question 18, we asked, do you think that ADAS features improve your attention to the road and surrounding environment? So we found that officers who trust ADAS to improve their driving safety also use ADAS while they're performing secondary tasks and believe that ADAS can improve their attention to roadway. From our technology acceptance model analysis, we found that officers' trust in the technology and also ADAS training has a significant effect on behavioral intention to use the technology. And the training itself is a significant predictor of the usefulness. So the training and trust in these technologies are key factors that can affect the acceptance of these technologies among police officers. From our phase 2 results, I want to highlight some of the most relevant and most important results. We found a significant effect of ADAS on drivers' minimum time to collision. So those officers which in those situations where ADAS was on, the officers had larger minimum time to collision, which shows a safer performance. We also found that in hazardous situations, when there was a vehicle in front of the officer and also there was a vehicle in the blind spot, officers demonstrated a larger maximum longitudinal deceleration when utilizing ADAS as compared to manual driving, which is showing in this figure. So in the most hazardous situation, having ADAS on was actually helpful in reacting faster and also reducing the probability of having a crash. We also found a significant effect of ADAS on officers' trust in the vehicle. And officers reported a lower workload in the situations where blind spot monitoring and the forward collision system with emergency brake system were on as compared to manual driving. So I'm going to jump into the discussion of our significant findings. From phase 1, we found that trust in ADAS positively impacts officers' intention to use ADAS. So since trust is based on drivers being able to effectively use and rely on ADAS feature, it's important to find a way to train officers on ADAS functionalities. And we think that by having this training the officers in real-world patrol situations, they will be more likely to implement the technology and use them as they become more expert in it. So research and manufacturers should concentrate on lining up the capabilities of what ADAS features can do with what police officers expect in order to build trust and encourage the ADAS use. We also found that officers who are educated in ADAS are more likely to indicate high intention to use ADAS than officers who are not educated. Again, this is emphasizing the role of training in ADAS use. And there are some approaches for training. Usually police department use, for example, classroom education. There's also manuals, paper-based manuals. There's driving simulation-based training some departments use, and there's multimedia software tools. Our prior studies also showed that using computerized training can be useful, which has a lower cost as compared to simulation-based training. And we also found that training can improve officers' opinion on usefulness of ADAS features. And when they perceive the usefulness of the technology and they can trust it more, and they believe that they can use it more often. From our phase 2, we found that officers had a larger minimum time collision when the ADAS was on. That means that they had more time to react to crash situations. In the combination scenarios, when we had a forward collision warning on and blind spot monitoring active as well, and when there was a situation when they had for example, vehicle in their blind spot, a vehicle in front of them, officers demonstrated a higher maximum longitudinal deceleration as compared to driving without ADAS, which is showing that, ADAS can be effective in safety critical situations. However, the impact of blind spot monitoring was limited, and we think that it might be due to the low salience of this feature, because there was a lack of auditory signal unless the officer turned on their blinkers. And we observed that most of the police officers in our study did not use their blinkers. And therefore, there is a need for improvement in the design of blind spot monitoring for officers to make them more noticeable. We found that officers reported lower workload in scenarios when ADAS was on as compared to the scenarios when ADAS was off, especially in those safety critical situations when the hazard was both a lead vehicle and a vehicle in blind spot. There was no significant difference in the workload responses between driving with and without ADAS during pursuit situations. This is very important, and I think we can explain that based on the Wickens multiple resource theory, because in the pursuit situation, the officer is under a lot of workload from different sources, from visual sources, from also auditory sources. The siren is on, the radio is on, there's a lot going on in the vehicle. And the activation of ADAS in these situations also provide additional workload because it requires visual attention, it requires auditory attention. So we didn't see the effect of ADAS features in this high demand pursuit situations. Therefore, our message is that the effectiveness of ADAS in police vehicles may vary depending on the driving condition and the cognitive demands that is imposed on the officers. And finally, we found that the use of ADAS can increase drivers' confidence in the safety of the vehicle because the trust that they had in the vehicle increased when the ADAS was on. And that could prevent and mitigate the impact of collisions. So increasing the trust can influence officers' behavior and decision-making. And studies have shown that when drivers have greater trust in the safety features of their vehicle, they are more likely to rely on these features to prevent crashes. So at the end of this study, we provided some guidelines. The first guideline is that we need to emphasize clarity above everything else. About 68% of our responders said that they would make greater use of ADAS if the functionality and advantages were more clearly explained to them. And since ADAS training can impact perceived usefulness and officers' intention to use this technology, improving officers' knowledge can potentially increase ADAS acceptance among law enforcement. Our second guideline is that we need to improve ADAS accessibility and usability. About 38% of our officers in the survey stated that there were situations that they preferred to have their ADAS features disabled. However, over half of the respondents says that they were unable to easily turn on or turn off their ADAS features. The third guideline was that we need to provide adaptive and personalized ADAS. Officers, as I mentioned in the previous guideline, prefer to have their ADAS off in some situations such as pursuit driving. However, it was not clear for them how they can do that most of the time. Also, ADAS should be compatible with existing policing vehicle technology. In the comment section of the survey, a lot of officers mentioned that these ADAS technologies are designed for civilian vehicles, and we are using mobile computer terminals. We are using a lot of in-vehicle technologies that are different from normal vehicles, and therefore these technologies are not adapted to our situation. Number four, the guideline number 4 is that we need to focus on perfecting a few features rather than having many less elaborate features. Officers have high mental workload in their job, and a few features can help them perform their duties effectively, can be much easier to understand and trust rather than a multitude of complex features that are not explained properly. Police vehicle ADAS features should focus on improving officer safety. We had very few officers that said that ADAS can reduce their mental workload. They all believe that their mental workload is part of their job and it's pretty high because of the use of secondary tasks. However, more than half of the responders believe that ADAS can improve their driving safety. So I wanted to highlight some of the limitations of our studies as well. In phase 1, many of the surveyed participants drove vehicles that had a limited number of available ADAS features, and this might have biased the findings in favor of few ADAS features that are currently available in their vehicle. And in phase 2, our participants were all males, and while about 20% of law enforcement officers across the U.S. are females, this might limit the generalizability of the findings to overall officer population. And the experiment was done in daylight driving and may not be generalized to night shifts. So future studies are needed to solve and to fill these gaps. At the end, I wanted to thank the student researchers in this study, Vanessa Nasser, David Wozniak, and Farzana Shahini, my graduate students. And also, I would like to thank Safety for supporting this study, police departments across Texas for participating in these project, and also the Texas A&M Engineering Extension Services, Law Enforcement and Security Division for helping us recruiting participants. And we have published some of the findings of this study in papers in Transportation Research Part F, and also Transportation Research Record, and also in the Human Factors annual conference. So if you wanted to read more about it, please feel free to let me know. I would be more than happy to share that with you. And thank you so much.
Thank you very much for all of that information and for sharing everything with us. At this point, I'd like to open it up for questions. I know it's a little bit of a different scenario. If you have a question, another option is you can also just raise your hand. I can then open your line up to talk as well, so you can ask your question in person. So if anyone has a question that they want to ask directly, just go ahead and you can put your hand up and I will get to, or again, you can put the question in the question and answer section that is at the bottom of your screen. There are like two little talking bubbles, I guess, and you can go in there and you can also put in your question and I will relay that. So either one, whatever is most convenient for you. I have a question though, just for starters. So Maryam, from your experience working in this area, what other technologies in police vehicles could possibly reduce the driver distraction?
Yes, thank you, Laurel. So I think the technologies in police vehicles, they are very highly demanding, you know, using mobile computer terminal, using radio, for example, they're doing multiple tasks in the vehicle. So our studies, we have proposed some guidelines on how we can reduce the clutter of this display, how we can use different modalities of information presentation, for example, using auditory signals, using visual, using tactile information. So I think those can be useful in reducing workload, but I think the goal should be to provide technology in a way that understand the cognitive state of the police officer. So for example, in one of our recent projects, what we are doing is that we are designing the technology based on the cognitive workload of officers in real time. So when, for example, their heart rate variability shows that their workload is high, or when their pupil size shows that their workload is high, the technology adapts itself. So it can go to, for example, low clutter mode when the officer is not on the high workload. So I think these context-aware technology is the solution, in my opinion, to be able to reduce the workload in real time for the officers.
You.
Yeah.
You were talking also about just being able to, that a lot of the officers said that they weren't sure how all these systems worked and things like that. So how do you suggest the training should be for these officers who might want to use these technologies?
Yes, yeah, that's a good question. And, I think our next plan is to look at what are the best approaches for training for officers. But from what we have seen police officers do, usually, for example, using classroom training, on-road training is very important because their experience on road with these technologies is the key to how they use it in the vehicle. We also think that driving simulation-based training is potentially can improve their performance. Some of the departments use this technology to train the officers. So I think a combination of them would be useful. Some studies have shown even very easy implemented computer training solutions. For example, variable priority training is one of the well-known approaches of training that can be easily implemented in a game, which can improve officers' multitasking performance, for example, and improve their knowledge, for example, of the driving situation. So I think there is a need for investigation into the best training approaches, but I think multimedia training solutions and computer version solutions and driving simulations are good options.
Thank you.
Mm-hmm.
We have a question from Kirti. I hope I said that right. I am so sorry if I did not. In the phase 2 of the simulator study, did you check any combinations of modality and task to check workload?
We did not manipulate the modality of the information. So it was the secondary task only presented information visually, and the question that was asked was through the driving simulation. So no, we did not check the modality, but we assessed the effect of whether the secondary task was present or not, and the effect of that on workload. And it was a significant effect. So when the officers were performing a non-driving related task, they reported having significantly higher workload as compared to when they were not using a secondary task while driving.
Thank you. All right, I am going to just take this moment to let everybody, if you have any more questions, go ahead and you can type them up, or like I said, let me check real quick to see if there are any hands raised. But I also do want to let you know, just briefly, that we do have a next webinar coming up. It is going to actually be next week. We don't normally have them that fast, but we do. We have one on July 19th coming up, and this is going to be the one that was rescheduled from last month. So if you missed it, don't worry, we've got it covered for you. It is going to be on evaluating the safe routes to school transportation program in the socially vulnerable communities of San Diego County, California, with Dr. Gabriela Fernandez and her graduate student. So from San Diego State University. So she's going to present her findings of evaluating the safe routes to school. And it will be at the same time as this one, so 2 o'clock Eastern Standard Time on July 19th. I have dropped the registration link down in the chat, and you can go ahead and register for that if you would like. All right, let me see. I do not see any other hands up or any more questions coming through. We can go ahead and stay on in case anybody else does have a question and you're still typing it out or trying to figure out how to raise your hand. Again, thank you for bearing with us as we try this new way of hosting the webinars. But if that's all,
Yeah, I'm going to
would like to
also,
Mhm.
Laura, sorry, I'm going to
go
also
ahead.
just write my email address in case, you know, some people has questions, they can directly contact me via email.
Yes, and this presentation as well as the slides will be available within a week. And so that you can be able to go to that project site that's already in the link, and you will be able to get the video recording of this as well as the slides that she presented today as well. And you also get an email alerting you that they are up once they are up if you have registered. So, all right. Well, thank everybody very much for joining us. And thank you, Maryam, for hosting and telling us all about your research. We appreciate it very much.
Thank you, Laura, for hosting this. Appreciate it.
All right.
Bye.
Bye-bye.